Chapter 1. AI Data Management. My aim was to conduct research that aligns more closely with real-world scenarios rather than being purely theoretical. Therefore, instead of relying on research datasets, I collected samples through image crawling. I believe understanding how to collect, refine, and label raw samples is essential for AI recognition systems. These experiences are crucial for me to establish a solid foundation in AI recognition design. Chapter 1-1. Raw dataset to training datasets. I collected 305,492 image samples from Google, Flickr, and Unsplash. These samples are organized in a tree structure, with 8 grandparent, 144 parent, and 627 child folders, as shown in table. They are stored within each child folder. I designate the initially collected samples as the raw dataset. Within this raw dataset, there is a range of samples, varying from highly correlated to the label to those with minimal correlation. This figure illustrates several filtering algorithms designed for the 3 training datasets. These algorithms selectively gather samples highly correlated to labels from the raw dataset. Ultimately, 53,786 training samples, 17.6% of the raw dataset, are selected. They are effectively categorized based on sample quality as training dataset 1, 2, and 3. Since there is not a clear method for selecting the collected samples highly related to each label from the raw dataset, I developed Filter 1 to generate the core dataset. In Filter 1, 2 samples are randomly chosen from the raw samples for one label, totaling about 10,000 pairs. 4 methods assess the similarity between the 10,000 pairs, selecting the top 10% based on their scores. Each pair is divided, and samples occurring more than 10 times are grouped together. Then, employing a 5th method, the group with the highest average similarity among the 4 different groups is chosen as the core dataset from the raw dataset. The Filter 2 algorithm is straightforward. It essentially reapplies the Filter 1 algorithm to the core samples already chosen by Filter 1. As demonstrated in this figure, Filter 2 selectively collects more core samples from the core dataset to create the gold samples. This dataset of gold samples is referred to as Training Dataset 1. This video showcases some samples corresponding to 3-level labels in Training Dataset 1. Chapter 1-2. Non-gold dataset to Training Dataset 2. After Training Dataset 1 was obtained from core dataset. As illustrated in this figure, I applied Filter 3 to the remaining samples to create Training Dataset 2. As depicted in this figure, Filter 3 operates similarly to Filters 1 and 2. But it distinguishes itself by randomly pairing samples from the non-gold dataset with samples from the gold dataset. Chapter 1-3. Non-core dataset to Training Dataset 3. Training Dataset 3 is composed of the samples remaining after Filter 1 selects the core dataset from the raw dataset. These remaining samples form the non-core dataset. As depicted in this figure, Filter 4 selectively collects non-core samples by randomly pairing samples from the non-core dataset with those from the gold dataset. Other procedures remain consistent with Filter 1. Chapter 1-4. Data results. With the implementation of 4 filter algorithms, as indicated in this table, 17.6% of the raw dataset was chosen as the training datasets. Training dataset 1 comprises samples refined after double iterations, while training datasets 2 and 3 are further refined from the remaining samples. Thus, sample quality is determined by training datasets 1, 2, and 3.